right, in this video, I'm going to show you, I'm going to introduce to you about some factoring polynomials. There's a lot of different ways to factor polynomials, and I'm going to have a video of each different way. This video specifically starts off with just factoring out the greatest common factor, which this method that I'm going to teach you today, you need to always check. Anytime you have a factoring problem or assignment, looking for a greatest common factor is something that you need to do with every single problem. So I'm going to remind you that throughout the next few videos. But let me just show you first just problems that just focus on finding the greatest common factor to complete the problem. So take a look at this first problem. It's 24y squared minus 18. Now, the greatest common factor, remember this word factor is part of a multiplication problem. And we're looking to see if 24 and 18 share a common factor. So the same number could be used to multiply by another number to get 24, and that same number could be used to multiply to get 18 as well. So depending on your background in math, this may be easy to find out, or it may be pretty hard. Especially in this case, we want to find the greatest common factor, not just any common factor, but we want it to be the largest. So let's take a shot at this one. The first thing I want you to notice is 24 and 18 are both even numbers. So 2, the number 2 is definitely a factor of both of them, but it may not be the greatest factor. So next, let's look at the number 4. 4 goes into 24, but it does not go into 18. Okay, I'm going to then go up to 6. I skipped over 5 because these numbers are not divisible by 5. 6 is a factor of 24, and 6 is also a factor of 18. Then we could continue to go further, but 12 goes into 24, but not into 18. So I think 6 is our greatest common factor. Okay. It's also important to look at the variables, but in this example that I have for you, the first term has 2 y's, the second doesn't have any y's, so they do not have any in common. So 6 is our number. I want you to write down the greatest common factor first, and then I want you to open a set of parentheses. And what we're going to do inside this parentheses is I want you to rewrite our original expression after you've divided 6 out of it. Okay, this word factor out, you could swap out the word divide out. Okay, so 24y squared, when you divide out or factor out a 6, you're left with 4y squared. And then when you factor a 6 from the negative 18, you're left with negative 3, and then close parentheses. Now, to check to see if you're right, there's a couple things you can do. The first thing is you can re-multiply the 6 back through using the distributive property. You can also take a look at the 4y squared and the negative 3 to make sure that they don't have any other number in common, which they don't. And so your final answer for this part, this is as far as you can factor it, is 6 times 4y squared minus 3. Okay, let's go ahead and try another problem. Take a look at this example. We're still going to just practice this idea of factoring out a greatest common factor. Let's first look at the coefficients of negative 15, 5, and 10. Hopefully the first number, the first factor that pops in your head is a 5, because they are definitely all divisible by 5. Now I want to point out something to you interesting. Because the leading coefficient is negative, most often your teacher will want you to go ahead and factor that negative out first. I tell my own students that teachers never want a negative student or a bad student to be the line leader. So we're going to go ahead and factor this negative out when we factor the 5. So So I'm going to put a negative 5 out, but we're not done, because if you notice, they each have an x variable. Okay, the first term has 3x, the second one has 2 of them, the last one has 1. So what they have in common is only 1. So I'll go ahead and put that next to our negative 5, draw an open parentheses, rewrite this expression after you have factored out the negative 5x. Don't forget about the negative. So taking this first term, when you factor out negative 5x, you have a 3x squared. It's a positive 3x. When you factor out the negative 5x from positive 5x squared, you are left with a negative 1x. You don't have to put that 1 in place. And then when you factor the negative 5x from the positive 10x, you're left with a negative 2. Okay. Again, there's 2 ways to check this. I think that the best way to check this is to multiply this outside number, to go ahead and distribute it back through the problem to make sure you get the original problem. You can also look at this expression here in the parentheses and make sure that there is no other common term that you can find. Okay, let's do one more problem together. Take a look at this one. This one should look different to you, primarily because there's 2 variables instead of 1 like before, but I guarantee you that this problem is just as easy as the previous 2. Okay, we're going to just do this step by step, where first I want you to look at the coefficients, and then I want you to look at what x term they have in common, how many x terms they have in common, and then I want you to look at the y terms that they have in common. We'll just take it a step at a time. First I want you to look at the 21 and the 35. I want you to start going through your multiplication tables. What times what equals 21? What times what equals 35? Hopefully you have landed on a 7. Okay, so I want you to write 7 down. Next, take a look at these x terms. The first term has 2 because it's x squared. The second term has 6, which is x to the 6th power. But in common, what they share in common is only 2. So we will write the x squared in place. Next, we have y to the 5th in the first term, and then only a single y in the last term. So we really can only say they share a y in common. It's a common factor. Okay, so 7x squared y is the greatest common factor. Now I want you to open a set of parentheses and then rewrite the expression, what the expression would look like after you factored out the 7x squared y. Okay, so what that looks like, when you do the 21, you factor out the 7, you're left with a 3. And then when you factor out the x squared from the x squared, you have no more x terms left. And then when you factor a single y out from y to the 5th, this kind of is leaning heavily on your knowledge of exponents rules. We're going to subtract here, so this will be y to the 4th. All right, and then we're going to go on. This will be a 5. When you take x squared from x6, this is another subtraction problem. And then you have a single y, and you take out a single y, you factor out the single y, you have none left over. Then we're going to close parentheses. Now, even though, I want you to look at something, even though both of them have an exponent of a 4, because those exponents are attached to different variables, they still have nothing in common. And of course, the 3 and the 5 don't have anything in common. So for right now, as far as we can factor, this problem is to what we have here. So now it's your turn. I want you to pause this video and try some of these on your own.